Hello everybody, my name is Andy Langdon. I'm a naturalist with the Elkhart County PD Park Department, and today we're continuing our series on nature A to Z. Okay, so this month it will be the letter P for Perseids, because we're talking about the Perseid shower. The Perseid shower happens every year in August. It starts around the 17th of July and continues on through the 24th of August. And the best time to see them is the 11th, the 12th, and the 13th. So what is a meteor shower, you might ask? Well, the Earth is traveling right now. We're traveling through space at about 67,000 miles an hour. No pit stops, no stopping for gas. 67,000 miles an hour. Now we are spinning around at about 1,000 miles an hour. But as we're traveling through space, we intersect a comet's orbit. And that comet has left all kinds of debris, all kinds of space dust, if you will. And space dust if you won't. But all kinds of space dust. And our Earth goes right through that space dust at around 67,000 miles an hour. Okay? Now, keep in mind that space dust is also traveling around 35 to 50,000 miles an hour itself. And so that is a lot of speed. And I'm going to tell you a little bit more about where comets come from, because in order to understand meteor showers, you've got to understand comets. Okay? So the comet is, it originates, we've got two belts here in our solar system. Actually, one is in our solar system. The other one is just outside the solar system. The one is called a Kuiper belt, and it's just on the other side of the planet Neptune and Pluto. So it is a belt that circles our solar system, and it is composed of these like billions and billions, probably more like trillions of these big cosmic rocks. Okay, so we call them asteroids. Asteroids are smaller than planets, so they're still huge, but they're smaller than planets. Okay, then you have comets, and comet is basically just a big galactic dirty snowball. Okay, so as it's traveling through space, it starts to speed up as it comes nearer the sun. So it's coming from this maybe the Oort belt or this Kuiper belt. We're not real sure which. The Oort belt, nobody's ever seen it before, and it is supposed to be probably trillions of these great big galactic boulders in space, and they are also traveling probably 50,000 miles an hour. They're really traveling through space. And so they have enveloped our solar system like a shell of an egg envelops the yolk of that egg. Okay, so we've got that all over. Nobody's ever seen it yet, but we know it's out there. And we also know the Kuiper belt is out there. So supposedly we've seen that belt that we're talking about. Now, Voyager 1 is traveling, 35,000 miles an hour. And it's going to take it 300 years just to reach this Oort belt. 300 years traveling at 35,000 miles an hour. And it's going to take about 30,000 years to actually go through this belt, this Oort belt that we're talking about, all these asteroids. They're traveling so fast that every once in a while they may collide with each other. Every once in a while, the gravitational pull of maybe a planet like Neptune may pull them into our solar system, and so we start to get these comets that build up. And like I said, basically a comet is it's just a mass of this dirty snowball, if you will. As it nears the sun, it begins to vaporize, and as it vaporizes, it's leaving a trail, and this trail is what the Earth intersects as it sweeps through space at about 67,000 miles an hour. So we're hitting each other at about 130,000 miles an hour. As this galactic dust comes through our atmosphere, remember, our Earth is intersecting their atmosphere, not the other way around. So as we intersect their atmosphere at about 130,000 miles an hour, so these particles of basically the size of sand, some are a little larger, they will burn up in what's called our mesosphere, and that's about 22 miles up. That's where we got this thin layer of gases, and as it comes through, it actually begins to heat up. Now, not so much the grain of sand. I mean, the grain of sand is not really what you see. What you're seeing is the air, the gases in the atmosphere that are being compressed so rapidly, so quickly by this grain of sand that's coming through at about 130,000 miles an hour. And so as it comes through our atmosphere, it begins to heat up the molecules of gases in front of it. And eventually those molecules of gases get to the point they get heated up so much that they turn into a very hot light. Okay, and that's what you see streaking through the sky, this space debris about the size of a grain of sand, and sometimes the size of a marble or even a pebble, which gets very bright. Basically, they're just flakes of iron and nickel left over from the comet's tail. So these, you've got your asteroids, and you've got your comets. And what's the difference between an asteroid and a comet? Well, it's kind of like saying what's the difference between a rock and a snowball. All right, all kinds of things. You hit somebody in the head with a rock, and it's going to disintegrate. The head, not the rock. But you hit somebody in the head with a snowball, and it's going to disintegrate the snowball, not your head, hopefully. But anyway, it's the same with this comet. This comet is a massive, and when I say massive, I mean huge. We're talking about the size of a city, all right? So maybe larger than that. So you've got your asteroid, which is like a huge galactic boulder in the sky, although it's we're talking about something that's almost the size of a planet. And then you got your meteoroid. Meteoroids are small, okay? They're just space debris ranging in size from about the size of a grain of sand to 330 feet. So anything larger than that is considered an asteroid. And then you got your micrometeoroids. And micrometeoroids are just particles that have come off of the meteoroid. And then you've got your meteors, and that is what you see up in the sky coming through. As it enters Earth's atmosphere, we call it a meteor. And then if it hits the ground, that's when we call it a meteorite. Okay? Remember that if they do hit the ground, it's called a meteorite. Before they hit the ground, it's called a meteor. So that's why it's called a meteor shower as it passes through the Earth's atmosphere. Generally, they burn up before they ever hit the ground. So the comet is going through space, and generally when you see these comets, you'll see a tail on them. As a matter of fact, the word comet actually comes from the Greek word, which was comet, which means long hair. So when you see a comet, tail of it, you'll notice that that it's long and beautiful. And so the Greeks thought it looked like hair. So that's why they call it a comet. And sometimes the tail is actually in front of the comet in the direction that it's going. So the tail will actually be before the comet. And the reason that is because as they're flying through space, remember there's no air in space to slow this thing down. So as they're flying through space, it's the cosmic winds that are caused by the sun that pulls all this debris off of this comet. As it nears the sun, it gets hotter and hotter and hotter and begins to vaporize. And so all of this dust, gases, water, everything off of this thing begins to vaporize because it's so close to the sun. And as it begins to vaporize, it leaves this trail of cosmic dust. So people have asked, do meteor showers happen during the daytime? Obviously they do, but you don't notice them because it's daytime. But every once in a while, you will notice a meteor so bright that it actually brightens up the sky in the daytime. Okay, so if you want to see these meteor showers, the best time to see them is after midnight. Morning hours, when there's very little moonlight, go out in the country, that's the best place to see them because you don't have the light pollution back there. So as you're going into, as you're viewing these, you're going to look for Cassiopeia. Okay, so look in the north for Cassiopeia. So right below Cassiopeia is the Perseids. So if you can't find the Perseids, look for Cassiopeia. Okay, if you can't find Cassiopeia, look toward the north for a big W in the sky. If you still can't see it, big W in the sky, try waiting till the sun goes down. August 11th, 12th, and 13th is the best time to view these things, because that is when we're in the heart of this meteor shower. So that is the best time, 11th, 12th, and 13th of August. Okay, that's when you're going to see most of these beautiful showers. About once every minute, you should see a shower after midnight. They call it the Perseids meteor showers because the showers tend to originate from the Perseids constellation. So the Perseids constellation is right below Cassiopeia. Now, it doesn't matter where you're looking in the sky, you're going to see it anyway. But you want to see the most of the showers, you're going to look north toward Cassiopeia and the Perseids constellation, which is just underneath the constellation Cassiopeia. You're always welcome to join us for the Perseids party at Bonneville Mill County Park in Bristol, Indiana. We'll be at the Briar Patch Shelter from 8:30 to 12 on August the 13th. So I hope to see you there. So once again, this is Andy Langdon with the Elkhart County Parks Department. We're continuing our series of Nature A to Z, and with the letter P for Perseids. And I hope you can get out and enjoy those meteor showers August the 11th, the 12th, and the 13th. All right. Thank you for watching, and see you next month. Bye.